Okay, I'll just let you talk
Hmm.
because it's pretty bad the feedback. Just when I was going to say that you were going to give an overview.
Oh, yeah, yeah. Oh, all right. So as an explanation of this video, this will be a walkthrough of Cyberfrack, how to set it up, all the different features that it includes. This will be more of a holistic overview of everything. So as you know, Cyberfrack was developed to transition wells automatically using controls and automation in the field. So we have um, wells displayed on the Cyberfrack pages that reflect the frac stacks out in the field. And these little triangles are your valves or your devices. If you select them, you can open or close them. Open is green, red is closed. And another thing worth noting on this device is right now these valves are set up for hydraulic mode. So this little box above the triangles, this is your handle position on the Cyber Hub or the Mini Hub. So if the Cyber Hub physical handle position is in the open position, it'll display green, it'll display red for closed. Typically these line up with each other. However, there are situations where in this case, it is reading a valve position. However, it's not picking up a handle position. So they're independent of each other and they can read differently. And that can flag a user that something is wrong. Like maybe there's a blockage in your line and your handle position is closed, but your physical valve position is still open. That's a problem, right? Um, the little E inside that box stands for energized. And that simply means that you executed a valve move in Cyber. And when you execute a valve move using automation, it will lock the handle into position. So if I walk up to it and physically try to move it, I can't move it. It's hydraulically locked, energized. As soon as you put the Cyber Hub or Mini Hub into manual mode, that's when the E goes away and you're back to just well, I don't have any pictures of it, but it'll just be a regular box with no E in it. And your energize goes low, and then you can physically move that handle back and forth.
That's just a solenoid.
Yes. Yes. And so that energized concept, it's really just a matter of it's a means of making sure that we don't make any valve moves without cyberfrac. If you have an emergency situation and you need to move that valve, that's when you go to manual mode and you start moving stuff. However, the goal is cyberfrac does all the work and we are locked up on those hubs and nobody can mess with them. That's the goal anyway. Um, so field overview, we can take a look at 4 wells at a time. So I have 4 wells on the first page. If I select this arrow here, I can look at wells 5, 6, and 7. This is a holistic view of your wells. And on these pages, you will see, we'll go back to the first one. I have a frac manifold here. I've got isolation valves listed. The isolation valves are placed in between every well. And I can move my pump truck location in between these ISO valves, depending on where it comes in the field. We'll get into the pump truck stuff once we get into CP simulfrac because it's easier to visualize. However, you can still visualize pump truck locations with these ISOs. And beneath these ISOs, like I said, we have all 4 of our wells, and your frac stack is listed accordingly. This P stands for pump down. This F stands for flowback. So my pump down line comes in above my upper crown, my lower crown. This is my UMV, and then this is my lower master valve. In between the UMV and your crown valve. So in the system, we refer to this valve as the crown or the swab, interchangeable. We do not call it lower crown. We don't call it lower swab. However, we do call this valve the upper swab. So just keep that in mind. If someone says the swab valve or the crown valve, they're referring to the lower one all the time.
Okay.
Little confusing. These two valves here, these are your zipper valves. I don't remember off the top of my head, but I'm going to say this is upper zipper, lower zipper, and then your flowback. You've got your inner flowback, your outer flowback. Now, I can look at the status of all my wells. So I have wells 1 through 4, and my status for well 1 is frac, and these other 3 are standby. And as you continue to look at these screens, you can tell what phase they're in by knowing the valve position. So I see both my zippers are open, my upper crown is open. Naturally, I'm in frac. I can see that these guys are in standby, and that's true because all my valves are closed. UMB can be open if my pump down is above my crowns. If my pump down was coming in right here, then for standby, my UMB would be closed. We have to make sure we block pressure from the pump down line. Also on this page, you're going to see frac transducers and pump down transducers. We have a total of 3 frac transducer devices. We have 2 pump down transducer devices, and we have 1 flowback. As of today, I've never seen anybody run a flowback device. They typically don't monitor that line. It's just open to a tank, so it's there for future use, but right now we don't use it. And then pump downs 1 and 2. You're going to use 2 pump downs typically if you have a dual wireline situation. So I might have 1 wireline crew here, 1 wireline crew here, and wireline typically will only work on its own set of wells. So wells 1, 2, and 3 might be wireline 1, 4, 5, and 6 will be wireline 2, and your pump down pressures will be assigned accordingly. Okay. Yeah, and feel free to interject with questions or whatever.
Yeah, so right there, I've seen Taylor do that, but I know you can interchange those transducers. You can pick what channel they're coming from.
You can change them based on well selection. So if I go to field configuration, this is where you would say, hey, well 1, I want you to talk to PD2, and well 2, I want you to talk to PD1. Is that what you were asking?
No, can we go back to your screen?
Mhm.
I think what I saw you do was you were reading from, say, like that. I can't remember which one was it. Can we go? I think it was, yeah, right there. Yeah, that. So that frac pressure, number 3.
This guy?
Yeah, or number 2. Yeah, you can make them read from a different transducer.
Field config or the
Yeah.
sensor config.
Yeah, I guess.
Pump truck locations?
No, like when you assign like frac pressure 3 is like well pressure 2, like well
Oh,
pressure 3 port.
yeah. Yeah. Yeah, we can get into that in a second.
Okay.
I'm just going to run through the cadence of explanations of pages and whatnot. Is that what you wanted
Yeah.
with this? Okay. Okay, so yes, field overview. You got your various transducers, various wells. If we hop to the well pages, all of these are identical. Well 1 is in frac. Like I said, green is open, red is closed. So both my zippers are open, upper master is open. Technically, I'm fracking. You would see your frac manifold pressure show up here on the right side, left side, sorry. Tree pressure shows up here, and well pressure shows up down here. I have pump down pressure, I have wireline pressure, and then I have flowback pressure. All of these transducers can be hooked up physically, but they don't use all of them. The only one that you're really required to use is tree pressure and frac pressure and pump down pressure, because those drive all of your interlocks. If you're missing one of those, you're limited on what we can provide interlock wise. Because I need to stop you from opening certain valves in certain cases. If, perfect example, I have 4,000 PSI on the tree pressure, I need to have a reading on frac in order to keep me from opening these zipper valves. If I have 0 PSI here and I open these zipper valves, we're going to blow pressure right through the line. Same goes for pump down. So we make a lot of comparisons to say, what is tree pressure versus frac, or what is tree pressure versus pump down? And then if you have additional sensors, like wireline pressure and flowback, it's just an added benefit. We can get more interlocks applied at those points. On this well page, this is where you make all of your phase selections. So I'm in frac right now. If I wanted to go to standby, I would select standby and select request phase change. When I select request phase change, you'll notice that this guy populates over here in the bottom. This is our sequencer. If I want to see all the steps in the sequencer, I could expand it. In this case, I'm going from frac to standby. So my sequencer is saying upper zipper, the action is going to be closed. And it currently has an interlock active, so I can't even touch it. And lower zipper is the next step, number 2. We're going to close this guy. Once sequencer is executed, the system will auto-complete and you're back in standby. So we can show this. If I hit request phase change, if I don't have any approval set, it'll just automatically execute. So like I said, sequencer is moving everything for me. I don't have to touch a thing. If I do not want to use sequencer, which some customers do not, you can turn this off, in which case you would select your valve and you would open and close yourself. Yeah.
That's what we were talking about yesterday, right?
Mhm.
Okay.
Yeah.
You'll notice,
Oh.
sorry. You'll notice these little locks show up here on the left side of all of these valves. So these locks mean that your valve is interlocked. If there is no letter inside the lock, it means that you're neither allowed to open or close. If there is an O, it means that you're interlocked from opening, however, you are allowed to close the valve. And then if there is a C, you're not allowed to close, but you are allowed to open.
Okay.
What else? So we made a phase change request. We select these buttons over here, submit it. Like I said, there are approvals. So you may, if you have them on, you'll see them pop up. They have to make the approvals in order for it to go through. I guess we could just do a quick look at the sequencer. The sequencer, as it stands right now, is more or less auto updated on its own. So we don't really need to change these steps. However, if the customer has a custom operation that they want to do themselves, they don't like the way that we have our steps ordered here, you select this button, it'll disable the auto update. Select checkout, and now you can modify your steps. And all this means is on my frac tab, I have standby to frac, I have frac to standby, so on and so forth. What's my order of operations for each step? So standby to frac, I want to open the lower zipper first. I want to open the upper zipper second. The little letter here on the right side indicates the open or closed. So O for open, C for closed. If you want to simplify this view a little bit, maybe it's too busy, select this button. We'll get rid of the operation steps. And then here at the bottom, we have pause before step number. I have, if I say, hey, I want to pause before step number 1, when it goes to execute sequencer, it will pause before it starts step number 1, and it'll wait for you to resume it. This is typically used for equalization.
Do I have like a resume button or?
Yes, on the sequencer it does, yeah.
Okay.
Yeah, so if I go to wireline, typically we throw pauses in there as an added step. The system will auto pause on interlock. However, if you wanted to be super safe and you're like, hey, it's going to take me 5 minutes to equalize my wireline to the tree pressure, I would say if we're going from standby to wireline, we're going to execute outer pump. Well, show operation. So we will open outer pump, we'll open inner pump, we will open the upper crown, and then we have to equalize. So I said pause before step number 4. Once you equalize, you can hit resume and it'll just open everything. Assuming you have no interlocks, right? Even if you hit resume, it'll still watch for interlocks and make sure it doesn't bypass anything. So that is the pause before step feature. And then here on the right side, we have a couple of somewhat useful stuff. This pending thing, this is, if I made this 10 seconds, when the phase change request is approved, the sequencer will wait, it'll pend for 10 seconds before it starts the very first step. So it'll just say pending and it'll wait 10 seconds and then first step executes. It's just a way for me to add some time because sometimes people are a little more cautious. They don't want sequencer to start right away. They might want to ease into it.
So the pause requires me some interaction, right? It requires me an action from the HMI and say resume.
Yes.
And the delay, it just continues, just takes a little extra time.
Yes.
Okay, gotcha.
Yes. So typically we don't put a pending delay. We just go right in the sequencer. So it's set to 1 by default. This is the delay in between steps.
Of course, it's really late.
So the delay in between steps is set to 1/4 of a second, but just like pending, you can set that as long as you want. Say, hey, I'm going to execute step number 1. I want to wait 15 seconds before I execute step number 2. The rest of these we don't really mess with. So I don't think we have to get into them, but some of them are self-explanatory, like auto retries. So if the valve fails to respond, the sequencer will send another request up to 3 times. I can tell it to never send another request, in which case it would be 0. If the valve fails to respond and it tries however many auto retries you have set, after that, it'll say like valve failed to move and it'll just lock up and you need to go fix your valve, basically.
Well, I've seen, and this is just from some pain points in the past. I've seen sometimes valves, they have their own retry counter. Especially Rotorks, I've seen that they have some retries, right? So how do we match that with their configuration?
So the Rotork, does the Rotork have a retry? I don't think so.
I think it just stops, and if it can't move, it just doesn't move.
Yeah,
It has a torque limit, and if it hits that torque, it just done.
fail as is. However, you may be referring to, there is a little bit of I think we could do better at the syncing up like the time delays that we have. It's like our sequencer has an expected travel time.
Mhm.
Rotork may have one. I don't know if it throws an alarm if it doesn't travel within some amount of time. I'm not actually sure. But I think I know what you're talking about. There is some nuance to it because there's some weird relationships with timers in here.
Okay,
But
that's not the case here.
no, when it comes to this stuff, no.
I don't think you can, not a retry on that specific valve, is there? Like, when you actually go to the field config, that little gear, is there a retry there as well? I don't
I
think
don't
so.
think so, no.
I mean,
No.
I've never actually, usually if it fails the first time, I've never seen it work the second 2 times.
Right.
I think what I was referring to is called fail safe.
I kind of forgot about that function. But no one ever messes with those general set points normally.
Right. We have them pretty well worked out at this point. There was a time when it was like we had to keep adjusting stuff, but I think they're pretty well settled.
Yeah, that one, and then I think it was the amount of time it, like, the no response timeout.
Yeah.
I think that was the big one.
Yeah.
On when it's either hot or cold, takes a valve longer than a minute or 2 to actuate. Now everything's electric and it only takes like 30, 20 seconds to function now, but
Right.
those hydraulics, they get really slow and cold.
Mhm.
Those TFS valves took like 2 minutes sometimes in the cold.
Yeah. So annoying.
I'm trying to push molasses here.
Yeah. So that's where this does come in because hydraulics is still going to be a thing, but say you needed it to be double it's in the dead of winter, you're using 1/2 inch hoses, you may adjust your valve response timeout because I need the sequencer to understand this valve is going to take 2 minutes. I don't want you to flag it if it right. I don't want you to flag it because I know it's traveling, just hang out. Because if it flags it, then it goes through this retry protocol and it just gets really annoying.
Mm.
And then if your sequencer does get into a failed state, if I recall, your only option is to abort it and then restart the sequence. You can't resume.
Unless you fix that interlock. But,
Once you enter that failed state, I don't
oh,
think.
really?
Yeah, I
So
think
even if
that's
the valve ends up like finally getting to its state,
Mm.
it won't just say resume. Oh,
Mm.
okay.
that's part of the trouble of it.
Oh,
Um, we could probably have a separate video just on sequencer and how it works. There's a lot of different nuances to it. General modes. So this section is actually pretty helpful. If you are going through a sequence and an interlock pops up and it says, for example, you have to equalize this valve. As soon as you equalize, the way it's set up here is it'll proceed immediately. It's not going to wait for you to hit resume. So this is helpful for things like CP Simul, where if they hit an interlock in the middle of a transition, they equalize it, the system will just auto proceed and they don't have to jump to other pages to try to keep things rolling. If you have it set to pause, it'll pause immediately on interlock. Once the interlock clears, you have to physically hit resume. It's a little more cautious, so it really depends on the customer and how cautious they want to be.
And what we usually do?
Proceed.
It depends on the cost.
Depends. Yeah. Exxon doesn't care.
other customers just use proceed because that's quicker. They like seeing it, so okay, I equalized, go.
Just go.
Just
Yeah, but the scary part is if you're not expecting it and you equalize, maybe you wanted
Yeah.
to like do something, or I forget the scenarios, but there are situations where
That's
like
very rare.
it moves super fast.
Maybe new crews that have cyber, new customers that have cyber will have them on pause initially, but you didn't take them long till they're like, okay, I don't like it anymore. Sleep now.
And I do that resume from the customer's tablet, or can I do that from the MCS?
You'll do it from the MCS, and I'll show you what that looks like
Okay.
here in a second. The pauses, so these steps down here, you can disable them if you didn't want any pauses at all. And the retry,
You could also just put zeros down there.
yeah, you could overwrite these and just say, I don't want to pause for this one. And that's the same thing. I don't remember what the retry is, to be honest.
Is that just for if the valve fails and it retries, you have to physically hit retry if it fails?
Yeah, I guess it would
Maybe.
execute.
I don't know.
So maybe,
I've never.
oh no, you're right. You're right. So like you could tell it to retry manually.
Yeah.
Okay, I got you.
I mean, maybe, I've never actually seen it retry before.
Yeah, we've never modified that.
But it's still gonna go, even if it's manual, you cannot do that however many times you want. I mean, you just
Yeah,
gonna
set
stop.
to 3.
Okay.
Yeah, and this 3 is what determines the sequencer failed state. Once you're in failed state, you're out of luck.
Okay.
Um,
Then I need the board.
Hmm.
Then I need the board if I go to fail state.
yes, you need to abort.
Okay.
So I think we will do a separate video for sequencer because I just think it's too much to
Mhm.
get into. But the last thing to note about sequencer is this auto update steps. So if I made any changes over here, I can leave it and I can check this in and it will accept my changes and it'll use them. However, this auto update, if I prefer the standard way that we do stuff, if I select this, it's basically explaining to me that any changes I made here is going to be overwritten with our standard table. So if I enable this, it's just going to rewrite all this stuff. It's going to put my pauses back to the way they were, things like that.
Very cool.
Yeah. And we have a sequencer for frac, wireline, offline pump down. And we also have a dart drop. but you have to have Dart enabled on your stack, and then that tab will pop up. Okay, so that's your well pages. Let's get into field configuration. I'm gonna have to leave in about 10. But this field configuration page, you can access your pump truck information. So your pump trucks are, these are how we define the frac pressure calculations. So I have frac bank. I call them pump trucks. We now call them bank A, B, and potentially bank C. If I go back to this well overview, field overview page, you'll notice that I have pump truck number 1 coming in on the left. We have what we call the cluster gateway, which it calculates all the nodes required to understand if this valve is open, then I have pressure from pump truck number 1 feeding well number 1. If this valve is closed, wells 2, 3, and 4 are isolated from pump truck number 1, right? That's important because when I go into frac on well 1, it needs to display the correct frac pressure. This is coming from pump truck number 1. However, this guy is not seeing any pressure. So when I go to frac it, it's just going to read nothing or 0 PSI, or actually don't know what it would read in this case, but it wouldn't give you a pressure because you're isolated right here. So that's where if you have several pump banks, you can put these in specific locations that make sense based on your field setup. So pump truck number 2 might come in right here at well 3. And because this is open, the system understands, okay, wells 2 and 3 are seeing frac pressure 2. Well 1 is seeing frac pressure 1. Well 4 is isolated because this ISO is closed. So that's how it does all of its calculations. But all of that can be defined here on this page here. I have these pump trucks. They are devices in the system. If I select the settings, this is where I get access to pump truck information. So I can modify the name if I don't like bank A. This guy here, if I select this, it'll open a table. And it is complaining because I currently have frac bank stuff set up. And we'll have to get into that in a later video. But just to continue with our cadence on this one, I can modify the bank stuff here. If I select the settings and I select this location table, it gives me options for where that pump truck's going to land. And I can say, oh, I want to be left of ISO 3. When I do that, if we run back to this well field overview page, all of a sudden pump truck shows up to the left of ISO number 3. And, you know, that's how we set those up. And like I said, you can have up to 3 pump trucks. So this guy might be, so it's left of ISO 6 right now, which is off on the other field overview page. Hit this button over here and we can see pump truck number 2 shows up to the left of ISO 6.
So I can assign it to wherever I want. Can I
Yes.
do it to L7 if I wanted to?
Yes, sir.
Okay.
Yeah, the farthest you can go is the left of ISO 8. This is ISO 8 here, out of service at the moment.
And what prevents me from not double assigning things?
There's logic in there to make sure you can't do it.
Okay.
Yeah.
So I cannot mistakenly assign. Okay.
No, and you cannot put pump truck 1 to the right of pump truck 2.
Okay.
So it has to be in order 1, 2, 3. Always.
Okay.
And so if that's why we gave you the ability to change the name.
Mm-hmm.
Say you want bank C on the left, it's always going to be pump truck 1 device, but you can name it whatever you like.
Okay.
So
Makes sense.
yeah. And the reason for that, actually, without getting too deep into the CP simul page, is the way logic is written. It's always going to be pump truck 1 devices here on the left, 2, and then 3. And based on logic, we said bank A can't cross bank B. If I move this to the right of bank B, well, then everything gets all confused. Okay, so that is part of the field configuration page. So we have several tabs. We're looking at the well overview. Well overview is where you access your pump truck information. It's also where you access the set points that we use to drive all sorts of interlocks. Each of these could be explained in detail. The text is a little hard to interpret what it means. So DP stands for delta pressure. So we're saying your delta pressure across the crown valve can be no more than 500 psi. Basically, what we're saying here is in order for me to go into a wireline transition, which I will do for the sake of explanation, because I can show you already in wire. This guy, stand by. I think. I don't. Okay. Didn't want to get into this, but we do have a wireline key. So if you are going to go from wireline to standby, you must select this key, say yes, the tool is in the tool trap. This verifies that wireline is completely removed from the gate valves in the main line, because the biggest risk you have with wireline is cutting it. So if it's downhole and we close one of these valves, we're going to cut wireline. That's going to cause a lot of problems. So in order for you to get back to standby from a wireline phase, we require that the wireline tablet has that little soft key. They select it and they say, yes, wireline has been removed, at which point the user then has the ability to transition to standby. They would make their approval process. Once their approvals are made, this is typically where I would put a pause. Now, normally, if you were to do a regular wireline transition, you have just closed this crown valve. Tree pressure was, say, like 4,000 psi. This whole line is still pressurized. In order for me to close the rest of these valves, I have to bleed off that pressure. So pump down is sitting at 4 grand. It's not going to let me close these until this is 0 psi. You'll also notice that I have a C in my lock here, that interlock. As I had mentioned, you're allowed to open these pump down wings, but because there's a C, you're not allowed to close them. And that's because your upper crown here is still open.
And now you have to bleed.
Typically you would bleed, you would close this upper crown, and then it'll let you close these pump down wings. However, what I wanted to show you was this is the resume button for a sequencer. So anytime it pauses, it'll give you that option to resume. That's all. The other thing I was going to show you is the explanation of these guys. DP across crown. Basically, if I was going into wireline, the delta pressure across crown is an example of that would be, let's pretend I'm going the other direction. Let's pretend I had just opened this, opened this, opened this. My tree pressure is 4,000 and my pump down let's pretend it's 0 psi. In order to open the lower crown, my tree pressure and my pump down pressure must be equal or greater than. Pump down pressure can be greater than tree pressure up to 500 psi.
Yeah, it makes sense. You have to push it down. Okay.
Yes, and that's where all these set points come in. And we could probably have a separate video on that explanation. Just what do all of these guys mean? But that's where my calculations are all based off of. It's like, hey, you're allowed to be equal to or greater than 500 psi, DP across UMV, different valve, different phase change. So maybe I have a different set point. So I say, oh, well, UMBs, it can support a higher pressure differential. That's all defined by the customer and how they want to handle it. Continuous pump affects this as well. Typically, continuous pump transitions, you could be upwards of 4,000 PSI differential pressure, as opposed to just, a couple hundred. So these will drive those interlocks. This last thing down here is your land sensor. That's specific to speed lock. You can either have it out of service or you can have it in service if you're using one.
The lock is the nipple looking thing that comes on top.
That is, yeah, there's a switch. Yeah, whenever the speed lock comes down, there's a switch that it hits.
Yeah.
And that's what indicates it's landed.
An upside down bail.
Yes.
Okay.
Yes. And we have two different types of sensors out there. Eventually we'll just have the one, but that's why we have a normally open or normally closed, depending on the type of sensor you're running. Gen 1 was normally open and Gen 2 is normally closed. Maybe. Don't is it? Okay. Okay, so then we take a quick peek at our valve assignment. This tab here, this indicates all of your wells. Each well has its own set of valves on the stack. All these valves are listed here. You can have valves that are out of service, which means that they will be grayed out on the valve stack itself. If we're not going to use them, we'll ignore them. If they are in service, then you must have them assigned to something or otherwise utilize them in some way. So you'll notice that I can't really mess with anything here. That is by design. If you want to change your handle assignment, which is this first column, handle assignment is referring to the hydraulic device. So your cyber hub or your mini hub, each of those has a function on it, open close function. If I want to assign this to a cyber hub, I would have to make that selection here. In order to unlock that, we'll go to the systems box, select field modes, select config functions. As soon as I select config functions, the lock button goes away. And I select this guy.
There's 3 menus to make it to enable selecting these. I mean, you want the 3 pop-ups, so you could enable that.
Yeah, there's some things in here are a bit cumbersome. I think they were just carried over from years of how we did stuff. Potentially room for improvement. So, yes, basically how this is denoted is the first 2 digits are your either cyber hub or mini hub number. The cyber hub is always going to be 01, 02, or 03 because I have 3 of them listed here. And then mini hubs start at 4. So if you see 4, 5, 6, 7, all the way through 12, that is automatically a mini hub. And then your functions they exist based on however many handles are available to you. So if I go to a mini hub, I've only got 4 options. The rest of these are out of service because mini hubs only have 4 functions.
You can make those mini hubs into 16 handles, right?
You always could, but it's not going to work.
Because they have PS.
Oh, well, I see what you mean. Like you can make it a cyber hub. You can. We did fix that. We should probably test it.
Yeah, well, we've never had more than
3 cyber
hubs on a job.
Yeah.
So we never needed it, but
I want you to be late for your next meeting.
Yeah, we're gonna hop out. So that's a start. Yeah.
Start.
It's